I'm going to talk about the topic of simultaneous equations. What does that mean? Well, simultaneous means at the same time, or and equations, well, you've heard the word equation before. It's to do with something equal to something else, and when you have a number of variables, one or more variables involved. So let's take an example. So let's say this again is an example from Mathematik 5000. There are two girls who are going on holiday and they're checking in their baggage, and they weigh their baggage at the check-in. So Lynn and Alice weigh their hand luggage. The total weight they found is 13 kilograms together, and the difference between, the difference between the weights of their bags is 3. Kilograms. How much do their bags weigh? Now this probably isn't a very good example, because you could just weigh the bags individually, but that's we'll forget about that now. We'll work with this problem. Now, the first thing when you try and solve this thing is, well, you have to give a variable to what you don't know. So what is it that you don't know? Well, you don't know the weights of Lynn's and Alice's hand luggages. So let's call, you have to introduce variables. Let Lynn's bag be X and Alice's bag be Y. So we can let them be any value. And now we can write down an algebraic expression for their weights. So we know that the sum of their weights is 13. We can write that as X plus Y equals 13. And the difference between their weights is 3. The difference is X minus Y. So here we have one equation involving X and Y. We're told that the sum of the weights is 13, so X plus Y equals 13. Here we have another equation. We're told the difference in the weights is 3, so X minus Y is 3. And since these two equations both involve the same variables, Alice and Lynn's bags, then we say that these are a set of simultaneous equations, and you put a little curly bracket around it like this to show that it's a set of simultaneous equations. This bracket means that we have a set of simultaneous equations. They're both going on at the same time. And we want to find X and Y. Well, how do we do that? Well, we can try different values of x and y and then find the values that agree for both of these sets of equations. Or another way of saying this is we could plot these are both straight lines, we could plot the straight lines on a coordinate system and find where they meet, and the x and y values where they meet will be the solutions of the equation. So I'm going to do it by solving finding the equation of the straight line and then plot them on the graph and then find the solution graphically. So this is the graphical solution. So let's take this first equation, x plus y equals 13. Well, I want to find it in the form y equals. So if I subtract x from both sides, I get y equals 13 minus x. Let's take the second one now. I want to get y equals. This time I have to move this y over to this side and move this 3 over to this side. So we get y equals x minus 3. So this is the set of simultaneous equations. I just move them around to get them in the form y equals. And now either I can do a table of values or I can plot them in my graph. Let's do a table of values. So I have, let's do x and let's call this y1 and this y2. y1, y2. So let's say let's try x equals 1. So when x equals 1, y1 equals 13 minus 1, which is 12. And y2 equals 1 minus 3, which is minus 2. Now, since these y values are not the same, this is not the solution of the equation, because if it was a solution, these values would be the same. So that one we can rule out. Let's try 2. When x equals 2, y1 equals 13 minus 2, which is 11, and y2 equals minus 1. Again, not the solution of the equation. Try again, x equals 3, y1 equals 10, and y2 equals 0. Keep going, x equals 4, y1 equals 9, y2 equals 1. We're getting closer. Here we had a difference of 14, here we have a difference of 8. X equals 5, y1 equals 8, and y2 equals 2. I'm going to have to rub this out, and then we've done 5, so we're on 6 now. So if x equals 6, y1 equals 7, and y2 equals 3. For x equals 7, y1 equals 6, and y2 equals 4. But for x equals 8, y1 equals 5, and y2 also equals 5. 13 minus 8 is 5, and 8 minus 3 is also 5. So we've actually found the solution of this set of simultaneous equations. When x equals 8 and y equals 5, then both of these two equations agree. So let's try it. We've got if we take x equals 8 and y equals 5, 8 plus 5 equals 13, and 8 minus 5 equals 3. So we found the solution of the equations. Now another way to solve this would be not just doing a table of values and trial and error, would be using your graphical calculator. So let's get our graphical calculator, clear the screen. Now I want to plot these pair. You have to have the equations in the form y equals in order to do this. So you go to your y equals, you plug in the equation of the first line, which is 13 minus x, and then the second one is x minus 3. Graph them, and there you go. I'm just going to change the window. In order to find the solution to this set of simultaneous equations, you have to be able to see the intersection of the two lines in your window. So make sure that you change your window to see the lines crossing. Now to find the intersection, you go second, calc, and then intersect. Second, calc, intersect. Then you're given 3 questions. Choose a first curve. It's flashing on this curve, so I press enter. Second curve, it's flashing on this curve, I press enter, and then a guess somewhere near to the intersection. You can go left and right with these arrows here, and then enter, and it'll tell me the intersection is x equals 8 and y equals 5, which is a solution to the set of simultaneous equations.